right. Quick review. Friday was basically climate change day. We went through basically the current effect of climate change with the understanding that, further raises in temperature will at least continue those things. Then we looked at a nice, happy video about how wolves change rivers. Let's talk about the last 4 environmental issues. And then I'll show you another feel-good video, because that's how we roll this chapter. Desertification is like just what it sounds like, unless you think it sounds like putting whipped cream and a cherry on something. Desertification means the changing of previously fertile water-filled land into desert. Basically farming, overgrazing, pulling the plants out of the soil. What happens is erosion, and erosion is basically the sliding of the topsoil, the fertile stuff, off of the contours of the land, flattening it out, and the soil loses its ability to hold water. Quite a few ways to farm more sustainably. Here's a few. Crop rotation. Not just corn, soybeans, but more diverse crop rotation can help keep nutrients in the soil. Big time grazing area rotation is the kind of thing that used to be hard, and now there's really no excuse not to, because anybody know anyone or in a family where there's herd animals, where you got cattle or sheep or something like that? The technology that basically made it a snap to change where animals are grazing each time, do you know? What is it? What do they use to keep their animals in? So if you're taking them out and actually grazing them on grassy areas, you want to change where they are each time. There's these just like electric tape fences that like pull up stakes and move them. It's really easy, and the cattle won't touch them. So it's real easy to change where your animals are eating now. So it's become much more easy to rotate grazing areas. Certain ways to harvest instead of yanking the plants out, roots and all. There are ways to leave the roots in. That holds the soil together better. And then finally, if there are contours on the land, in other words, if it's hilly land, that's the kind of thing that farming can cause to flatten out and desertify. Contour farming, actually planting along the curves of a hill, can help keep that erosion from happening. These are basically, there's like 4 of these that are totally connected, right? So freshwater depletion is absolutely connected to this, right? Because it's this kind of desertification that decreases the supply of fresh water on Earth. Deforestation, whereby about 80% of the old growth forests, by old growth we mean ones that have never been logged, but basically a non-renewable resource because they take hundreds of years to reach that top phase. 80% of that is gone, and over half of just plain old tree cover, whether it's new or old, has been removed from our planet. And of course, that has lots of effects. More CO2 in the air because trees are what take it out. Less water in the land because trees hold water in the land. More erosion. And of course, stuff lives in trees. So taking the trees means less wildlife. There's some ideas here, some things already being done. Instead of clear-cutting forests, just taking every 3rd, every 5th tree, so that there is still a forest there. But of course, you don't get quite as much money out of a forest if you selectively log it. Tree farms, and couple that with the fact that they've come up with some tree varieties that actually grow a little faster. Genetically engineered is what that, maybe I should change that to
GMO. That's more common now.
So desertification, deforestation. From there, we move to a different type of ecosystem. Aquatic ecosystem, because humans really like to eat fish. The interesting thing about fish, if you imagine yourself in the grocery store, the good part of the grocery store, which is, of course, the outer aisles, right, where all the real food is, and you think about all the meats you can find in the grocery store, what's different about seafood? It's true that seafood lasts less long. That's a terrible way to say that. Seafood goes bad faster for various reasons. There's something else, though. Something else fundamentally different about the fish you eat versus all the other meats. Armani? I like the grocery store. One of my favorite places. It's where all the food is. Chicken? Where'd that come from?
Chicken farm.
Chicken farm? Yeah. Beef? Hamburger? Where'd that come from? Cattle ranch. Yeah. Bacon? Pig farm. Tuna? Ocean. Yeah. Like, there are some fish farms, right? Aquaculture is a thing, and it's going to be on our solutions list. But it's the only meat you eat that's wild caught. You know, unless you hunt deer, unless your family hunts deer, that's about it, or maybe turkey. So no wonder there's, this is tragedy of the commons and overpopulation, right? There's a lot of people to feed, and fish can make you a lot of money if you catch them. And so basically, TOC stands for tragedy of the commons. International waters, where it's very difficult to enforce any fishing regulations at all, make this a perfect example of the tragedy of the commons. Think of, international waters as a big bucket full of, $100 bills. Anybody can catch fish there and bring them home and sell them for lots and lots of money. So of course, people get better and better at catching those fish. Solutions, rotate fishing areas, just like you rotate grazing areas. The problem is enforcing those things on water is hard. You need cops in boats. And there's a lot of water. Add to that, you think about the East Coast of the United States, there are many families that completely rely on fishing. They saved up to buy a boat. They've been fishermen for, generations, and that's how they feed their family. And regulating what they can take home can really, hurt them economically. So you have to be very careful. Aquaculture is a good idea. That's farming fish, right? But one of the issues with that is that it takes lots of water and space, and those farms tend to pollute the surrounding areas. So problems come with it, but still, it's probably the way we're going to end up going as those food fish run out. I'll show you a couple of graphics of how fish are changing in a second. Actually, I'll show you right now. So this is what happens. Basically, the fish don't run out. It's just the big ones do. Right? And so you see something like this, where it's the same fishing pier in, I think, Florida in 1957, 82, and 2007. These are the record fish for those years. You can see certainly there is a difference, right? Same scale for each one. So that's what overfishing looks like, and it's changed things pretty much everywhere that there's good food fish. Biological magnification is the last one. It's kind of a different animal. It's not a specific area or ecosystem. It's that there are certain toxins that our industrial processes put into ecosystems that are weird, because they look completely harmless at first, because they don't hurt anything that lives in the water. Because of course that's where most toxins wind up, right, in the water. The first case of this that was discovered is a chemical. It was a pesticide called DDT, and what they found was, this was billed as like the safest pesticide there was. You can spray it on a tomato and then eat the tomato, and you were fine, right? Which is true. Modern biomag examples are mostly heavy metals like mercury, strontium, and what happens is they don't hurt the little base of the food chain aquatic critters that filter, feed, and they get some of that DDT in them or that mercury in them, and they're fine. The problem is that stuff sticks in their tissues, and you remember how energy and biomass are lost, right, on their way up trophic levels. There are certain toxins like DDT and mercury that aren't lost at all. So what happens is whatever's eating say the krill at the base of the food chain is having to eat a whole bunch to get the energy they need, right? And then 10% of that energy has been lost from energy use from the level below it, but none of the toxins. And what it's basically doing is magnifying up trophic levels till you get to the very top. And it tends to only hurt the top predators. The famous example of DDT is famous because the woman who discovered it, Rachel Carson, wrote a book called Silent Spring about DDT, and it was called Silent Spring because basically it was the birds that were getting killed by DDT because it didn't hurt anything below them, but then those birds of prey that ate fish and small animals, it hurt them by decalcifying their eggshells, and all their eggs broke. And so all these birds pretty much almost went extinct. Bald eagle was the most famous example. It's probably why we were able to ban DDT, because everybody loves bald eagles. That rule of 10% is what gets you, right? 10% of the energy gets lost, but 100% of the toxin gets passed up. And so you're basically multiplying by 10 each time you go up the trophic level. DDT was banned as a result of that book. And the predator bird populations have definitely bounced back. Bald eagles are doing great, so that's another success story. But the heavy metal stuff is still around. Raise your hand if you're into fishing at all. You don't have to get a license yet, right? Well, how old do you have to be?
I think I do now.
Okay, like 16 maybe? Yeah. So when you do, pay attention to the book they give you with your license, or maybe it'll just be a website. But if you go there, I promise what you'll see is a list of all the lakes and rivers you can fish in Ohio, and how many fish they recommend you limit yourself to eating wise, not just catching, not the catching limit, but how many fish you should eat from, say, Lake Erie in a month. And the reason that limit is there, and it'll be much lower for pregnant women, is because of heavy metals stuck in those fish's tissue, because of mercury mostly. I think it's mostly mercury. Yeah, so this is a modern problem that, that they have to sort of decide how many fish is acceptable and isn't going to cause harm to people eating out of public waters. Here is kind of a just visual. Pollutants, usually they go in parts per million, is how they measure them. And so say it's 2 parts per million in the water, these little plankton, they're filter feeding all day, they're going to get 20 parts per million. And then the stuff that eats the plankton magnifies by 10 again, and by the time you get up to the bigger birds, then they are in trouble. And of course, you eating a bunch of fish from Lake Erie, you're kind of like that grebe or the bald eagle, right? You're a top predator. Questions? I think that's it. Let's make sure. Yep. Yeah, polar bears are cute. Let's see if I can get this to play. I probably have to stop recording.